trigonometry. First up, we need to start talking about radians. So do you remember, up until this point, whenever we've been using our calculator, we'll remember at GCSE we always say check the mode of your calculator, change it to degrees. Okay? The reason being is that there is another measure that you could use, and that's radians. And that's going to give you a whole different answer. Radians are alternate units used for measuring angles instead of degrees. Okay. Oh gosh, this is going to be fun, isn't it? I think. Okay, so 1 radian, okay, is the size of the angle formed at the centre of a circle by 2 radii. Here we go, here's the circle. It's 2 radii, yes? And if those 2 radii, whatever they are, is the same length as this arc, that means that would be 1 radian. Okay? No. Alright, so you've got 2 radii, any length. The arc length needs to be the same length as those, not straight across, so the curved bit. That would be 1 radian. Okay? So R and R only. Correct, Monday. If you've got R and 2 lots of R, it'd be 2 radians.
How come there's 2 lots of? No.
What I'm saying is how it changes. So so the R and the R have got to be constant, obviously, but the arc length is the bit that can change. So if that arc length was now double, then the angle would be double, so it would be 2 radians. Yes? If it would be 3 radians. Because yes, get the idea. Not so important that you understand, remember this. You really just need to remember the conversion, but I'm going through it just so you've got an idea. Okay. So we know, don't we, that the circumference of a circle is 2 pi r. Yes? So that means that half of the circumference would be pi r. Yes? Suppose the answer. So what do we know is this angle usually? Half of the circle, 180. So that means that if this was r, this was r, and this was pi r, then this would be pi radians. Following those pictures just now? Yes, because when it was 1r, it was 1 radian. When it was 2r, it was 2 radians. So if it's pi r, it's going to be pi radians. Like that. That means that, where have I written it? Oh, pi radians is equivalent to 180 degrees. Okay? Says the answer. So, that means that our conversion is always going to be based on pi and 180. Okay? If we are converting something from a degree to a radian, we multiply it by pi over 180. So that's all you need to know. Pi over 180. Now, on the non-calc paper, you may be asked to do these kinds of things. If it's on the non-calc paper, you leave everything in terms of pi. Okay, so you don't need to know what the decimal value is because it's on the non-calc paper. No one expects you to work out stuff like that. You'll be leaving things in terms of pi. So don't panic. And even if it's on the calculator, you can leave things in terms of pi. Okay? So if we were to convert 40 degrees, we would have 40 multiplied by pi over 180. Let's do this without calc. We know that when we're multiplying values, this is a whole number, yes? So secretly this would be over 1. And rules of multiplying fractions is that we do top times top, bottom times bottom, yes? Now I personally am a canceller before I do my multiplying. I don't know about you. So I look at this 40 and 180 and I can see straight away that they can both be divided by 10. So I've now got 4 and 18. Because remember, if there's a number on the top and the bottom, you can divide by that. Yeah. I can see I've got 4 and 18, so I know that 2 goes into both of those. So I know that goes to there twice, and then 9 times. Okay. So I've now got 2 pi over 9. That's it, I would leave it like that. Okay, so 40 degrees would be 2 pi over 9 radians. Now, some people are like, is there a unit, like, is there a symbol for radian? Well, when I was a youngster, and you may see in some books, a radian was a C, but this is, like, don't stress about it. You can just say radians. Okay, so I wouldn't stress too much, but if you have a C, so half a degree sign, that would indicate it's radians. When we're doing these, actually, if you have your calcs, anyone have a calc? Yeah. Let's see what this actual value is. So what's 2 multiplied by pi divided by 9? So what is that actual number out of this? 0.698? Yeah. Okay, so you can see that that's a baby number, yes? Alright, that's a small number. So we're used to angle measures being quite big. What's our maximum usually? Not usually, always. So our maximum is 360 degrees. So what would 360 degrees be in terms of radians? Think about what we said that 180 was. 180 was pi, wasn't it? So what will 360 be? 2 pi, yeah. So we're talking for the max for the radians would be 2 pi. Now, what is the value of 2 times pi? 2 multiplied by pi. 6.2. Okay? So, the reason I'm saying this is that if you are working with questions and they haven't specifically said this is a degree question or this is a radian question, you are looking for small values. If they've given you small values, then it's going to be in radians already. Yes, does that make sense? So we know that it's not going to be more than 6.28. Okay, so if somehow you get an answer of 15.7, something's gone wrong. Okay, because our maximum value is going to be 6.28. Okay, good. As I said here, radian measure is often left in terms of pi. Not always, but it often is. Right, if you're changing from a radian to a degree, then you would multiply by the reciprocal of it. Okay? So you would multiply by 180 over pi. Now, if they've given you their measure, so if they've said it's pi over 6 radians, then it's a good way to think about it is, let me talk about the other way. Up here, the pi is on the top, okay? So when you multiply it, you're going to keep pi in your value, yes? If they've given you something in terms of pi, then your pi's are going to cancel when you multiply it by this one, because the pi's on the top. You'll see when we do this example, and maybe I jumped about a bit there. So we're converting this 3 pi over 2. We would multiply by 180 over pi. Now, as I just said, these things now cancel that because you've got one on the top and one on the bottom. Okay, and so that is, if you're ever not sure which way round it should go, that's the way I always remember it. That my pi is on the top when I'm changing to a radian because I want it in terms of pi, and then my pi is on the bottom because it's going to cancel out when I'm changing the other way.
But it's just like, even if it's, because that's pretty far, that's just far.
That's good, because they're multiplying together, so you're allowed to cross stuff out. If it's a 3 plus pi, it's no, you couldn't have done it. But because it's 3 lots of pi, you can do that, yes? I can also see that I've got a 2 and I've got a 180, so I'm going to do the 1 and the 90. And so now, I've only got a 1 left here. Remember, if you've crossed everything out, there's a secret one. Okay? So I've got 3 lots of 90, and 1 times 1, which is obviously just 2 sevens. And we would put our degree symbol in there. Sometimes it is helpful if you can have an idea of these values. So 3 pi over 2, that's, are you happy that that's 1.5 pi?
Yeah.
Yeah? And so we know that pi was 180. We know 2 pi is 360. So 1.5 pi is going to be somewhere in between. Okay? So whilst you're not always going to know whether this is completely accurate, because you may have something more obscure than that, just try and have an idea of the kind of number you're looking for. Okay? So if it's pi over 3, you know it's going to be less than 180. Yes? It's those kinds of things often help. What's happening now from what? Okay, so you guys have got these purples. You are almost done. So, hopefully you got the same as me, so 96, 260, 30. And then pi over 3, 2 pi over 3, pi over 4, and pi over 6. Now, there's a reason that I chose specific ones of these. The 45, the 30, the 60, they come up a lot. Okay? The pi at 90 degrees, the pi over 2 comes up a lot as well. And obviously the 2 pi does, as well as pi. So these values come up a lot. Yes, sorry.
This is in reference to, you know how like you would do 45 over 1 times pi over like
Yeah.
so I figured out. What did you?
I knew that 45 goes into 90 twice, and so it goes into 180 4 times.
Good.
But to be honest, you will recognise this soon enough because the amount we'll see it, you'll start to know. So the fact that 90 degrees is pi over 2 will come up a lot. And so then pi over 4 is just going to be half of that. The reason I say 90 is going to come up a lot, do you remember when we were doing trig graphs? Yeah. I think, or may or may not have talked about it then. So when we were drawing our trig graphs, remember our 4 main points were the 90, 180, 270, 360. So we will now appreciate that they are pi over 2, pi, 3 pi over 2, and 2 pi. So that's where those equivalent values, I think I drew them in on the graphs, maybe or maybe not, I can't remember. But that's why you're going to start to recognize those values quickly as well. Okay, so that's the pi of 90, 180, 270, 360. The 60 and the 30 and the 45 is going to come in because we have other angles. We'll shut up a second. Okay, that's good? That's right. So that means that questions can now involve radians as well as angles. The only time you need to worry about whether your calculator is in radians or degrees is when you are pressing those trig buttons. So if you are just calculating something using these values, then you don't need to worry about it. Okay? The mode of your calculator doesn't matter. If you are using tan of an angle, sine of an angle, cos of an angle, or tan to the -1, cos to the if you're using those trig buttons, then it matters which mode your calculator is in. You should recognize that if you get a weird answer, you're probably in the wrong mode. Okay? So you are going to become skilled enough that you check for that. Okay? So look, and you all know how to change your mode, don't you? I think we changed it to default to be a degree, but generally they default to be radians. So just double check what yours is. Okay, so that's that. That's it. Okay. So why are these radians useful to us? Okay, well, it means that we are able to find a new way of finding the length of an arc. Okay, so up until this point, what you may have been asked to do is to find an arc length, and you would identify which angle this was, and you'd say that it was that fraction of 360. Yes, do you remember how you've done this before? That's just from the outside, which does not. So if you were asked to find this measurement here, we know it's a portion of the circumference. Yes, so it would be this angle out of 360 multiplied by 2 pi up. Lovely job. This is a whole different way of doing it. But the principle is the same thing. So this length, the arc length L, divided by the circumference of it, has to be in the same ratio as theta over 2 pi. So Does that make sense? So this portion of the whole circumference has to be the same as this over 2 pi. Yes? Why 2 pi?
Because that's 360.
That's 360. Yeah, that's the whole way around.
Yes.
Are you with me? Yep. Again, you don't necessarily have to learn this. I'm just explaining where the formula comes from. You get given it, so you don't have to learn it. Don't panic. But it's just so you're aware of where it's come from. That means, therefore, that if we rearrange this bad boy, that how do we do it? L equals d to r, I think. So we've got L, so how do we find the circumference of the circle? 2 pi r. They all shout at once. They're secretly not.
That's right.
That's checks me out. So we've got 2 fractions here. That's not nice. So we should rearrange stuff. Now, how comfortable are you because 2 pi is on the bottom of both of them? Right. Would you be comfortable that I just cancel them out?
No.
Or would that freak you both out?
No.
No? So because it's under both of them, I can, she said she can cross out, but can she actually cross out? There's that one. No, that one. So that's now a secret one. Yes? So we've got L over R equals theta now. Yes? Mm-hmm. And then that means that the arc length L is just going to be theta multiplied by R.
Right.
And that's the formula that you get given. Okay, so the arc length is the angle measure multiplied by the radius. That's all you have to do. Yeah, totally straightforward. But the angle has to be in radians. Okay? How do you know if it's in radians? Well, if it's a small number. So they often have a diagram and it will say perhaps 0.2. Okay, you know that you're not going to have 0.2 degrees. You know it's already in radians. So whilst it should say whether it's in radians or not, you need to use your noggin to know that it is or not. If they said that, if they've shown that an angle is 72 degrees, you have to change that first to be radians, and then you can just multiply by the radius. Okay? Totally easy, nice, straightforward. L equals theta. Trig. Okay, sector area. Again, up until this point, you've been doing the angle measure out of 360 multiplied by how do you find the area of the circle?
Pi squared.
Pi squared. Excellent. Squared. So, same principle. The area divided by the circle area has to be theta over 2 pi. So we know that the area divided by pi r squared equals theta over 2 pi. Okay, so the only thing I've got on the bottom that's the same is the pi this time, so that's the only thing I can cross out. So let's cancel them bad boys.
Oh, nice.
It's crossed out. And now I've got a divided by r squared, so I'm going to bring that to my other side. So I've got a equals pi, that's not pi, theta r squared over 2. Now, secretly in the formula booklets it says a half theta r squared or r squared theta maybe. Okay, obviously all of these 3 things are the same. So you've got theta multiplied by r squared, divide that by boy by 2. Or you theta multiplied by r squared, multiplied by half. So whatever, exactly, centimeters and radians. Whatever happens, remember you're just squaring your radius. Okay, so please follow their maths. So you're not squaring the angle measure. And again, to use these formulae, your angle measure has to be a radius. Okay? nice, easy peasy lemon squeezy. So, I think we've got some examples, radians. So find the arc length L and area A of sector of circle radius 7 and sector angle 2 radius. Okay, I'm a diagram person.
Yeah.
I don't like lots of words. So I'd like to quickly draw a quick. Oh, shit now. Oh, maybe I'm not going to draw one. Maybe I can draw it over here because it's over here. Oh. Ignore that. So I've got radius 7 and the angle is 2. So the first thing they want is the arc length. So that's going to be, so that's just going to be 7 multiplied by 2. And this will be centimeters because it's a length. And the area will be a half multiplied by 7 squared multiplied by 2. Oh.
Actually, why did that give 7 meters?
Oh, because they said 7 meters there. Yeah. And are you good that my 1/2 and my 2 cancel out?
Sure.
So this 2 and this half is negative. So we've got that the area is 49, and this would be centimeters squared.
No, why?
Because it's area.
No, I have.
Because 2 lots of a half is 1 whole one.
You're right. You're absolutely right.
Not always, but usually.
Uh,
There are times that I am right. Yeah, Trippians? That says 49 very clearly. Centimeters squared. Let's get you. Because we knew that 7 times 7 is 49, didn't we? You didn't even use our calculator there. Awkward. Right, so arc length L, area A of sector circle radius 5, sector 150. What? Trauma. So this time we know this is 150 degrees, this is 5, and this is 5. So we said to ourselves, uh-oh, we haven't got a radius measure. So the first thing we need to do is convert it.
Yes.
So how do we convert 150 degrees into radius? What do I multiply by?
150 over pi over 180.
First the
Don't
answer.
you have to put that over 1?
If you would like, yes, certainly. I can divide both by 10. And then 15 and 18. What number goes into 15 and 18?
3.
First the answer goes into this sank and this cease. So I've got 5 pi over 6.
The number.
Whole thing. Were you not saying that I was bilingual?
No.
Someone was saying.
Miss Garza started to bring up some French
yes.
stuff.
Types, yeah. Anytime you use it. Right, so that's my angle. So now I can say that length is going to be r multiplied by theta. So we've got 5 multiplied by 5 pi over 6. Does the ends? That's r theta. That's equally over 1. So I've got 25 pi over 6. They did tell us to leave it in terms of pi, but if this was on a non-calculator, you'd have to. Like, you do not know what 25 multiplied by pi divided by 6 is. Okay? And you would not be expected to work that out. It would be a length measure though, so we would still say it's centimeters. Understand? And then the area, so that's a half multiplied by 5 squared. Multiplied by 5 pi over 6. So that's half multiplied by 25 multiplied by 5 pi over 6. This is equally over 1. So I myself would do 25 multiplied by 5. So you may have to do that without calc. Okay, so hopefully you would know that was 125.
Yes, ma'am.
And then 2 times 1 times 6 is 12. So 125 pi over 12, and that would be centimetres squared because it is an area. How close the end is that? Yeah. And you're probably thinking, well, surely that gets harder. Well, not really. And sometimes they might give you this measure, so the inside measure, and they want the big, something about the big part. So as you would do with any kind of question, so had they wanted us to find this arc length, and they told us that this was 2 radians, how, I need to know this bad boy. How would I do that though?
Well, why would you need to do it?
Because they want to know this arc length.
No, but I'm saying it, right? This is like another one. I'll be honest on it.
I mean, you could find the red one
No,
and take it away from the circumference.
area, because like the area is, you know, you can just multiply, subtract that from that. That would come with you.
But either way, you could find this bit and subtract it from the whole circumference, or find this area and subtract it from the whole area if it was the area. Or you could find this angle. So how would I find that angle though?
That?
What calculation would I do?
Maybe
What was the whole circle?
366.
In
Oh,
radians.
2 pi.
2 pi. This would be 2 pi. Yes. Minus 2. Okay. So you would leave your angle like that. Okay. So again, it could be on the long calculator. So if they've asked you anything about this bad boy, you would just leave it like this. So if they wanted the green arc length, it would be 7 lots of 2 pi minus 2. Yes? So that's 14 pi minus 14. Done. Leave it just like that. Okay? So that's the hardest thing that you might have to do in these kinds of questions. Okay? And that's not too challenging, is it?
Not at all.
No? Okay. So the back page is summary. So these are the formulae that you're given and trick tips.